Good morning. It's time for some Docker presentation. My name once again is Obi Agenti. My name hasn't changed, and today I'll be showing you a few things on Docker, just how it works, a few things behind the scene, and a few things on a command prompt, and also a few security things that might be interesting to just watch out for. And so to get started, I'll start off with the first slide that I have here on what happens behind the scenes. So you've got the Docker client from which you can run the command pull, run, and build. Now if I open my terminal here and I type the command docker ps, sorry, I need to be sudo password. I hope you guys can see my password from there. Very good. Now if I was to run this command docker ps, it just shows you now there's no command, there's no container running, but I can see what's going on. So the client is the terminal from which you can run this command, and the host or the server is the software that's underlying the hardware. So I'll go to the next slide here so you see what I'm trying to talk about. You have a bare metal system, dedicated system. You have a virtual machine here. So the virtual machine will have a host OS. It will have a hypervisor like a VMware, VirtualBox, and then on top of that you have your guest operating systems. Whereas on Docker, Docker runs on top of the operating system directly. So the Docker you have here is this guy here, who is your host or your client, and you also have a repository or a registry, which is a Docker Hub. So the Docker container and image, this is where they interact. So if you have one image, you can use one image to create several containers, and this registry is where you get your images from, which is Docker Hub. You can also get it from GitHub as well. Now to get started, I'm going to have a few commands that I'll just like to run just to save time here. So let's start off with the first one here, Docker Alpine. It's taking time here. Okay, alright. So if I paste this here and run this command, what happens here is it just checks and sees what's available. So it's looked up what I have in my Docker server with what's available on the registry. It's compared to both of them, and it's saying that what I have here is the latest. So I'll come back here again. Now I can spin up a container by using this command. So docker run switch itd container1 is the name of the container, and the image from which it's going to be found is Alpine. So this is the name of the container, this is the image, and this is the switch that I want. So this switch is interactive terminal daemon, something that run in the background. Now I can spin up a shell in this particular container by using the command docker exec it, and with this I've got a shell. So now I'm inside the container. I can check where I am. My working directory, it's root. I can ls, see what I have here. I can cd to home for example. Now I'm in home. I can check what's in home. There's nothing there, obviously it's still a new system. So this just shows you a few things that I have here. Now if I exit from here, I'm back on the root. If I type docker ps, I'll see this guy. This is the name of the image, this is the command I ran, this is when it was created, and this is the name of the container, container1. So the next thing I would like to talk about here, because I've shown you the comparisons of Docker and virtual machine just by virtue of this photo, is this Docker and Linux kernel. So Docker makes use of the Linux kernel. The Linux kernel has some extensive functionalities that are used, such as cgroup, namespaces, AppArmor. This is for security. These two guys are related to network, IP tables, firewall settings. Namespaces has to do with the PID namespace, the net namespace, and other namespaces which are like the building blocks of the Linux kernel. And then you have C groups, which I'll like to throw in a little bit more detail. Now Docker shares the Linux kernel. Now this makes it light, This makes it very flexible. At the same time, this is where the security challenges arises from. So when Docker started, they've used all of this. They've used the libvirt, they've used LXC. Currently they are using this lib container environment to connect to the Linux kernel. So talking about C groups, what are C groups? Well, C groups are Linux kernel features that allows you to limit the access that processes and containers have to system resources, CPU and RAM. So this is not IOP, this is I/O and network. So we can use it to limit apps to specific sets of resources. We can enforce limits and constraints, and it's one of the fundamental aspects of Docker container. So to demonstrate C groups and what we can do with it, I'll bring up my container again, and first I'll clear all of this. Then I'll try to delete all the containers that I've already installed so that it doesn't interact. So this command is going to stop it first. It takes a little bit of time. So the container is deleted. The next thing I'll do is to stop the container. The container is removed. So I'll bring up my command again and we'll start here. So I'm going to run this command again, which is same container, but just because I didn't want them to interact with the way I've planned this demo so everything goes smoothly. So I'll spin up a same container, same name. Now I have the container, it's been created. And then I'm going to run this command. Now this command is used to find all the C group entries that I have in this particular container. So if I run this, then I need to copy this container ID here, and I'll put it here, shift a bit. So when I run this command, what happens is it shows me all the entries that I have here. So the entries, the C group entries that I have are this one from here. I ran it twice actually, so it's from here to this point. Now what we're interested in is this namespace, the PID or the process ID. Now as I run this, I'll explain what I'm trying to do. So first I'll copy this, I'll cd into this entry, I'll cd into that, ls, what do I have here? Okay, I can cat PID s max. Now what this shows me here, because I can see that I have max under this PID's max, is this tells me basically that Obi, you can create the maximum number of processes on this container. Now this is a huge security risk because it implies that if a person tries to perform a DDoS attack, then the person can exploit this container and make it have an effect on the host. So how can we change this? How can we reduce or prevent this sort of attack on this container? Well, what I'll do is I'll spin up a different container that has a new set of parameters. Now I'm using the same command here, but this time I'm using this command PID's limit 6 on the same image. So let's do this and see what we're gonna get. So I'll spin this. Now I have a new container. A new container has been created, and that's the container ID. So I'm going to copy this just to cd into this directory and show you something now. Okay. So I'm there. If I ls, I can cat pid s dot max. Now when I run the same command that I ran before, when we checked the number of entries in PID S max, I saw that I had maximum. Now I have 6. So what this means is that this container can only create 6 processes before it's timed out. And so to test this, we're going to test this by first of all running a shell. We're going to spin up a shell. First I'll spin up a shell here, and remember, let me clear this so it's all clear. Now I'm still here inside the container and inside that particular directory. I'll spin up a new shell, and then I'll open a new terminal to show you something here. So I'll separate this here. Now I'll use this command docker start sudo docker start. Now what this shows me here is it shows me that I have 2 containers running. This container 1 is the one that has the maximum number of resources. The PID container has only 6 processes that you can run, and I've got 2 PIDs here. So having this in mind, now watch out for something. Now let's say I try to run this command. That's this one. Now if I run this command, watch what's going to happen. So this runs 5 times, because I have 1, 2, 3, 4, 5. It runs and it stops. Now if I try to run the same command again, and instead of having 6, because I have six processes, I try to have an extra one. So instead of having 5, because I've already set the limit on this particular container, if I try to put one more, it gives us this command. The shell can't fork, resource temporarily unavailable. So I can create more than 6 processes. So this is a method of mitigating this particular challenge, because what this means here is, in fact, let me explain by just going to the next slide. So the next slide talks about these dots I just spoke about. So it's an attack where a process or a group of processes use up all the resources available for the system, thereby affecting normal process of the system. The solution to counter such an attack will need OS level virtualization like IPC isolation, file isolation, controlling resource allocation. This is what we just did. Now Docker implements C groups to deal with such issues and ensure that a process doesn't take up all the resources. So that's what we just did. We created this container called PID container, which is this guy here, and we gave him access to just 6 processes to run. And as we can see here, as we can see in this shell, what am I doing? As we can see in this particular terminal here, we can run more than 6 processes, but we can run 6 on the dot. So that's the next thing that I'd like to show you. So the next point here is Docker Bench Security. It's a popular tool for auditing Docker environments. It comes as a container. It's easy to use, and what it does is it scans the whole container, and it shows you some of the things that will be flagged. So without taking much time, I'll just run this straight away. Now this is the command here. The command is this long command. It starts with docker run. It's a container on its own, and it runs on the system. So I'm going to exit from this shell. So now I'm here. I'll sudo su, I'm root. So I'll copy the command and I'll run it. Now watch what's going to happen here. I'm going to expand the screen. It doesn't take a lot of time, just takes a few seconds, maybe 10 seconds or thereabouts. So it's pretty quick. So watch what's going to happen. Okay, yeah, I've seen what I wanted to see. Yeah, that's cool. Okay, I think it's done here. Very good. So the whole check is done. Now it's giving me a score of 17 and it's checked 105 things. Now just a few things I just wanted to show you based on what we just created. Now it gives you a pass when everything is good. It provides info with a blue information. It gives you a warning because it's an auditing tool. So here it says ensure container is restricted from acquiring additional privileges. So this PID container and container 1 that I have, we did not restrict the privileges so we can become root on them. So that's one thing that we can check. Then it talks about the container health, about the both of them. It says we've not set the container health. Then talking about the PID, this is what we just did. Ensure PID group limit is used. Now although we did set it in PID container, it's not set in container 1, which is the first container we created. So by using this apparatus, we should be able to have a good system that functions and monitor all the changes and the security settings that need to be set up. So I'll go back to my slides and just provide a few more details. Thanks for listening.